cosmic dark ages. Roughly 380,000 years after the Big Bang, when the universe cooled enough for atoms to form, light wasn't yet being produced. This period is called the cosmic dark ages, and exactly when and how the first stars formed remains a complete enigma. The dark flow. In the large-scale structures of the universe, some galaxy clusters are observed to be moving at an unusual speed in a mysterious direction. This movement is called the dark flow, and it's thought it could be due to the gravitational influence of something outside our observable universe. The Great Attractor, our local group of galaxies and thousands of others around us are moving towards a colossal concentration of mass, roughly 250 million light-years away, known as the Great Attractor. What exactly this structure is remains unknown. Galaxy-sized voids. The universe contains vast empty spaces, or voids, where very few or no galaxies are found. How these voids became so large and empty could hold important clues about the early universe's matter distribution. The universe's foamy structure. The universe is thought to have a sponge-like or foamy structure with galaxies and galaxy clusters interconnected by filaments, while vast empty spaces lie between them. How this structure emerged is still an active area of research. The cold spot anomaly. On the cosmic microwave background (CMB) map, there's a colossal cold spot with a temperature much lower than expected. The reason for this anomaly challenges the standard cosmological model of the universe. The arrow of time. The laws of physics are symmetrical with respect to time, but why time in the universe flows in only one direction, from past to future, remains a great mystery. While the second law of thermodynamics, entropy, offers an explanation, its origin is still unclear. The vacuum energy problem, cosmological constant problem. Quantum physics predicts that even empty space should possess immense energy, vacuum energy. However, the observed cosmological constant is trillions of times smaller than theoretical predictions. This is one of the biggest unsolved problems in physics. The universe's ultimate fate. It's uncertain whether the universe will expand and cool indefinitely into a big freeze, eventually stop expanding and undergo a big crunch, or even be torn apart by a big rip. The nature of dark matter. Dark matter constitutes about 27% of the universe's mass energy content, yet we have no direct evidence of its nature. It's thought to be composed of exotic particles that are heavier than neutrinos and don't interact with regular matter. The origin of dark energy. Dark energy, which accounts for approximately 68% of the universe's mass energy content, is responsible for the universe's accelerating expansion. However, its origin and nature are completely unknown. What was before the Big Bang? While the Big Bang is considered the beginning of the universe, the question of what existed before it, or if there was nothing, is one of cosmology's deepest philosophical and scientific questions. Parallel universes, multiverse theories. Some theories suggest that our universe might be just one part of a larger multiverse. These universes could have different physical laws or dimensions. Space-time, inside black holes. What happens to an object that crosses a black hole's event horizon, or how space-time behaves at the singularity, is still a theoretical research topic. The origin of cosmic rays. Ultra-high-energy cosmic rays reach us from billions of light-years away. Their source remains a mystery, and while candidates like supernova remnants and active galactic nuclei exist, there's no complete explanation. Neutrino mass and the inverted hierarchy. Neutrinos are known to have a very small mass, but exactly how much mass they have and how this mass fits into the inverted hierarchy problem in the Standard Model is still an unresolved issue. The universe's thermodynamic fate. The entropy of the universe is constantly increasing, but is there a limit to this increase, or will it continue indefinitely? This raises significant questions about the universe's long-term thermodynamic destiny. Formation and evolution of galaxies. How galaxies grew into such large and complex structures, what influences their star formation rates, and exactly how interactions between galaxies work are still active areas of research. Matter in the voids between cosmic filaments. In the universe's large-scale filamentary network, very few galaxies are found in regions called voids. However, whether these voids are entirely empty or if they contain dark matter or rare gas clouds is still being investigated. The cosmological principle and homogeneity of the universe. The universe is assumed to be homogeneous and isotropic on large scales, the cosmological principle. However, some observations may show slight deviations that suggest this principle is violated at certain